Okay. Okay, let's see. Good morning, everybody.
Hello.
Good morning.
Good morning.
Good morning.
Good morning.
Good morning.
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 Kindle Rowan. Could y'all turn your, well, if you've got a camera, could you turn them on with your video? Just so I can see your faces. Okay.
Screen share?
Well, there's, okay, at the top or the bottom, you should see a little, looks like a little video camera. And if it has a line through it, then your computer is not showing you.
That better?
Yeah. I got to get to know you.
I sadly I don't have a camera yet, but I'm planning on getting one.
Well, it's not absolutely crucial. I just like to learn names and faces. Okay. And well, of course, usually it's I look out at a room and it's full of faces, but now it's a little different. Thank you for checking in a little bit early. It's kind of a pain when somebody, well, okay, yesterday was a mess for everybody, I think, but when people only join half an hour after the class starts and I'm talking about something and I have to switch screens and all that stuff.
To be honest, I've been on here since 7:30.
Really?
Same
Okay.
here.
Maybe even longer. I was trying to figure out how the Zoom thing worked. I didn't realize I had to download something to my computer.
Yeah, you do. Actually, whenever the invitation goes out and then there's a link, right? And you press on that link and there's an option to download the app right there if you don't have it.
I got everything set up, as you can see.
Okay, great. Yes, you do. Okay. Admit all. All right. Yeah, I have to admit everybody. But that's another pain. Okay, so I'm learning.
And this whole thing.
Yeah, there's a little picture of a video camera and a little picture of a microphone. And if it has a line through it, okay, either one, I can't see you and I can't hear you.
Good morning, Dr. Kennedy.
Good morning. What does that do? Oh, okay. Okay. I think I can use this to take roll. Okay. So never mind that. Let's see, how do I get rid of that now? There.
Seconds.
Okay. Two people entered the waiting room. Okay.
Just letting you know in case you need it. Sorry about that. Let my mom know the call had officially started.
Pardon?
I was letting my parents know that the call had officially started.
Okay. I don't want that. All right. Okay.
Huh. So it's recording me backwards.
What?
Oh, I was looking in the thing and I noticed that I'm wearing a novelty tee with words on it, and I noticed that the words were backwards.
Oh, yeah.
I didn't realize the camera recorded me in the same way a mirror would show me.
Mr. Rowan, I can't see you. I can see. Okay. The light's a little peculiar. There you go. Thank you. Okay. Okay. There's one more. One more. Okay, it's 8, but I'm going to give it a couple more minutes here before I get started. Well, okay, why don't I pick on somebody and get them to tell me about themselves? Kenya, tell me about yourself.
I'm a junior. I'm a biology major.
Okay.
And see, I'm from Port Arthur.
Okay.
Yeah, I don't know what else.
Hey, well, that's a start. Okay, how about Mason Smith? Tell me a little bit about yourself. I don't hear you. I can't hear you. Okay, I can't hear you for some reason. It looks like your microphone is on. Okay, I'll get you tomorrow.
Mason Smith?
Yeah.
No, Mason, your microphone is muted. There's a little symbol with a microphone cut through it.
Oh, true. Yeah, there's a little symbol of a microphone and a little symbol of a video camera. The microphone, if it's got a slash through it, then I can't hear you. And if the little video thing has a slash through it, I can't. Like, okay, well, let's see. Let's see how many we've got so far. 32. Okay, that's pretty good. Let's get started. Okay, so I'm going to share my screen and I'll try to go back and forth some because I can't see you raise your hands on my shared screen. And that makes it hard to get questions. If you have a question, well, let's just try this. If you say something, okay, well, just kind of interrupt me. And that could get a little chaotic if we're not careful, but let's just see how that works. Okay, so I'm going to share the screen now. Go to my notes. Okay, and then go to notes. Okay, and that's for my other calculus class. Okay. All right. So limits. We were talking about limits yesterday. Just started and I wrote the definition there again. We say that the limit as, let me get a marker here. Okay. The limit as x approaches a of f of x is L. Okay. A is a fixed number. L is a fixed number. F is a function from a subset of the reals into the reals, and this x is changing. Okay, you were taking x closer and closer and closer to a. Okay, so that's a notation we use, and that means that we can make the values of f of x arbitrarily close to this number L by taking x sufficiently close to the number a, but x not equal to a. The limit doesn't care about what f does at a. So we were looking at this example. The limit as x approaches 1 of x minus 1 over x squared minus 1. And that means the function then is this x minus 1 over x squared minus 1. And this particular function is not defined at 1 because you try to put 1 in, you get 1 minus 1 over 1 minus 1, and that's 0 over 0, and that's not a number. 0 over 0 is a meaningless sort of thing, so that's just wrong. Okay, f is not defined at 1, but as far as the limit goes, that's not important. Okay, so we looked at what happened to some values close to 1. In fact, I made a chart here and I put in more values. If you take x less than 1, and okay, so numbers less than 1, 0.5, 0.9, 0.99, 0.999, and so forth. These are numbers that are getting closer and closer to 1 as I go down. Yeah, getting closer and closer to 1. And the corresponding f values then, well, at 0, it's exactly 2/3. I wrote the numbers in decimal form because it makes it easier to see what they're getting close to. Okay. These numbers getting closer and closer to being a half, it looks like. And the same thing happens on the other side of 1. Yeah, for limits, you have to consider numbers less than 1 and numbers greater than 1. Because the limit has to do with what happens to f of x as x gets closer and closer to 1, and that means both sides. Okay, so numbers greater than 1, I took 1.5, 1.1, and then 1.01, 1.001, 1.0001, and computed those f's. Okay, and they are, okay, so now this is, these numbers are going down and getting closer to 1. At 1.001, so that's pretty close to 1 and 1/10,000th. The f value there is 0.499975. On the other side, at 0.99999, f value is 0.500025. So it really looks like the limit as x approaches 1 of x minus 1 over x squared minus 1 is a half. Okay. And well, this kind of approach always gives you evidence, at least, because the limit is what you're thinking about. What happens to f when x gets closer and closer to 1? What's f of x getting closer and closer to, if anything? And it looks like it is here. It looks like L should be 1/2. Okay. Any questions so far? Hey, don't hear anybody. Okay. Can we prove this? Well, let's do a little algebra here. Note that, look at x minus 1 over x squared minus 1. If I factor the denominator there, okay, I get x minus 1, and then x squared minus 1 factors into x plus 1 times x minus 1. And I can do some canceling. Oh gosh, there's an echo. I hope you don't hear it. Okay, so I can cancel out that x minus 1. It's a factor in both the numerator and the. Can you all hear that echo?
Yeah,
Yes, ma'am.
Yes,
Oh,
ma'am.
I think
no,
everyone
Because
should
some,
mute
think it's
unless they
Mr.
have
Miller.
just
something to
because some
say.
people are muted.
everybody
Yes,
mute.
ma'am.
It's from Mr. Miller.
Okay, thank you for that suggestion. That helps. Oh, I guess, all right, so, okay, so, yeah, we can cancel out that x minus 1. Now, and that's equal to 1 over x plus 1. And that's true as long as x is not equal to 1, okay? Because this function is not defined at 1. This function is defined at 1. And in fact, it's at 1 over x plus 1 is equal to a half. Okay, but this limit then should be the same as that limit. So the limit is x goes to 1 of x minus 1 over x squared minus 1 is equal to the limit as x goes to 1 over 1 plus 1 over x plus 1. And that's equal to a half because that's okay. Let's look at the graph of 1 over x plus 1. Oops. And I graphed it there. Okay, so does everybody understand how I can graph that? Okay, let me just put in a few more details here. Okay, 1 over x plus 1. Well, 1 over x plus 1 is not defined at minus 1, right? Because you'd have 1 over minus 1 plus 1 is 1 over 0. And that's not a number. Oh, yeah, that's not a number. So minus 1 is not in the domain of this function, but we don't care about that. Minus 1 is not very close to 1. And to get the graph, well, I have an asymptote, vertical asymptote as I get close to minus 1 coming in from the right there. But as far as the rest of it, I can just plot some points. If I put in 0, so, you know, points here. If I put in 0, I get 1, right? 1 over 1 plus 0. If I put in a half, I get 1 over 3 halves, which is equal to 2/3, and so forth. So I just plot some points, and I can put in a half, I mean, I can put in 1 itself here. When I put in 1, I get 1/2, okay? And so the limit as x approaches 1 over x plus 1, it ought to be a half. As if I take x coming in this way or x coming in that way, the values of f of x are going to be close to the value of f of 1 because the graph of 1 over x plus 1 is an unbroken curve. We're going to get some more terms to describe this, which I'm not going to use today or try not to use today. Yeah, but an unbroken curve, if your function is defined at a number and it's got an unbroken curve for the graph around that number, you can just substitute in, put 1 in. And yeah, g of 1 is 1/2. And that means then, okay, yeah, before I talk about that, what's the difference between the graph of g So that's G, okay, and its graph. What's the difference in the graph of G and the graph of F? Well, they're exactly the same, except that F of 1 does not exist because you put in 1, you get 0 over 0, okay? And that means if the graph of F has a little hole there where a point was on the other graph, okay, point there, hole there. But since the limit doesn't care about what happens at 1, that means that I can just get the limit of the original function, x squared minus, okay, untangle my tongue here, x minus 1 over x squared minus 1. The limit as x approaches 1 over this function. It ought to be exactly the same as the limit as x approaches 1 of 1 over x plus 1. And 1 over x plus 1 has this nice unbroken curve. I can get the limit of that one by just putting in 1 for x. And so it's a half, okay? We're going to do a lot more problems like this. But this is, okay, this does not exactly prove it, but it's a lot better evidence than just the numerical evidence that we were doing. And also a lot easier to do in some sense. You don't have to drag out your calculator and everything. Okay, so let me go back to you all and just see. No, okay. There, okay. Let's stop for a moment. Okay. Now, any questions? And now I can see your hand if you raise it. Anybody got any questions? Okay, Mr. Britton. Okay, you have to unmute your.
Yeah, I knew that. I was curious about something involving like homework for this week.
Oh, okay. I decided yesterday just to skip it for this week. Okay, I'm too worried about getting everything up and running and and get this running smoothly and get myself comfortable with the technology. And so you're not going to have your first assignment will be due next Friday. Okay. I'm very serious about homework, but there's a lot to deal with here, a lot that's new to me, probably a lot that's new to you, and that can just wait. And we do have 5 days a week every week, so that's going to help some. Any other questions from anybody?
You assigned the homeworks like right on Monday, right?
Okay, who's speaking?
Tristan.
Tristan. Okay, let's see if I can find you. Okay, there you are. Okay. Say again?
You assigned the homeworks like right on Monday?
No, I usually have the assignment to you on Friday, and it'll be due the next Friday. In fact, I will have the assignment ready for you this Friday for next Friday. Okay. It'll be a cycle. You'll get a homework assignment on Friday. It'll be due the next Friday. It'll be graded and returned to you, and it just keeps going. So you'll get the assignment a week ahead.
Yes, ma'am.
Plenty of time
Thank
to
you.
work on it. And also, you ought to plan on working on it throughout the week for the most part. Sometimes these homeworks are going to be long. So you don't want to leave it till Thursday night and be up all night trying to finish it. The first ones won't be that long, but they'll get longer and longer as time goes. Okay. As we get more and more into, how come I'm so narrow? Doesn't really matter. Anything else?
Jordan Hancock, you said the notes would be available to us. I'm trying to write them down, but we're going a little quick.
Okay. Yes. Yeah. I will send you these today. I didn't.
You didn't post. I can't find them on Blackboard.
Right. I actually posted the syllabus on Blackboard yesterday. So there is something on there now. And I have no idea who that man is.
Yeah.
I don't use Blackboard that much. I guess if, it's so clunky and hard to use. Oh, that fixes it. I don't like it. So I use it as little as possible. I will save these notes from today. I'll send the ones from yesterday too. I've written all over them, but whatever, I will email them to you. And I'll try to get into the habit of doing that. It's very easy to save the notes and email them to you.
Thank you.
Okay. Anything else? Okay, let's go back to talking about limits. Oh, okay, wait a minute. Let's see, 2 people entered the waiting room. Okay. And now back to the screen. Okay. Now. What happened? Oh, okay. There we are. All right. Okay. Let me do this. And let's consider this example. Now this is one function. Okay. It's not 3 functions. That's one function. It's just defined piecewise. So the function it's named f. Okay. F of x is 2 minus x. Okay, so this is this one. 2 minus x if x is less than 1. If it's x, if x is between 1 and minus 1. Minus 1 is less than or equal to x is less than or equal to 1. And it's x minus 1 squared if x is greater than 1. Let's sketch the graph of that. Okay, so let's see. The x-axis should not curve up like that. Okay, that's better. Okay, so it's 2 minus x, so I need more over here. If x is less than minus 1, put minus 1 right there. 2 minus x is line. And let's see, so I just need to graph a couple of points on it to know which one it is. And how about minus 2 and minus 3/2? That would be enough. Okay, and there is going to be a hole as far as this graph goes when I look at minus 1. Okay, so minus 2. I have to, minus 2 is less than minus 1, so I use this first rule. That's 2 minus minus 2 is 4. Call that 4. Okay, so that's a point on the graph right there. Minus 3/2, it's 2 minus minus 3/2 is 2 plus 3/2 is 4/2 plus 3/2 is 7/2. Oh, check my arithmetic, please, you guys. I make arithmetic errors all the time. I have to check myself a lot. So that's about, call it there. And then there, okay, well, if one's not, minus one's not in this piece, but what would it be if it were? It'd be 2 minus minus 1 is 3. So, okay, we'll put a little hole right there. And the first piece then is that line, okay? And that's a hole. All right. Now, the second piece, that's this one. Okay, so, well, let's see. Let's put minus 1 in. And that's another line. So I'll just grab some integers there. Minus 1 would give me minus 1. 0 would give me 0, and 1 would give me 1. Okay, so I actually need,
Excuse me.
yes.
I'm still in the -3/2. I really don't understand what it says.
What about the -3/2?
I don't understand what it says.
Oh, you
The
mean,
answer.
oh, you can't read it or you don't understand?
No, I can't read it.
Okay, yeah, that is kind of small. All right, so let me write it again down here. It's 2 minus 3/2 is 7/2, right?
Thank you.
Because it's 4/2 plus 3/2 is 7/2. A little better. Oh yeah, make my sevens with a little bar through it. Because I got used to doing that when I was living in South America, and it stuck with me. Okay. Okay, is that cleared up then? Is that okay?
Yes, thank you.
Okay. Yeah, now we're in the second piece, which is another line. And in fact, it's just the identity. So, whoops, forgot to do that. There, and call that 1. So 1. So that piece has that graph. And then the third piece, so now we're looking at this. Okay, so now we're looking at x is greater than 1. And let's see, so, well, 2 is greater than 1. Okay, may need to take something. Oh, how about 3/2 there? Let's see, why don't I do that? Just erase that. Okay, so I'll look at 3/2 and 2. And actually, okay, that's going to be a parabola, right? Can use that information. So just a nice U-shaped thing. Okay, and 2 minus 1 is 1. So that's going to be 1. Wait a minute, that's wrong. That was wrong. Okay, 3/2, that would be 3/2. Oops. 3/2 minus 1 squared would be 1/2 squared is 1/4. Okay, so let's check my arithmetic again. 3/2 minus 1 squared. That's 1/2. 1/2 squared is 1/4. And 2 minus 1 is 1, and 1 squared is 1. Okay, that looks okay. So at 2, we get 1. At 3/2, we get 1/4. Ah, yes. Okay. And okay, well, 1's not in this piece. But okay, so there's a hole there at 0 as far as this curve goes. This curve looks something like this. It's not a straight line. Too close to being a straight line there. Let me try that again. Okay. Well, it's a curve. Okay, so that's the graph of F. Okay, that's the graph of F. Now this point is on that second piece. The hole indicates those points are not there. Okay, so we said before that when you get a nice unbroken curve, you got the limits existing and you just plug into the function. Okay, well, where is this curve broken? Pretty clearly, it's broken okay, this is not a technical term. So, but it's broken at x equal to 1 and at x equal up to -1, right? And that's where you're not going to have limits existing. Okay. Let's see, what time is it? 6:30. Okay, this was just to remind myself what I wanted to talk about. I can move it. Nope. Down. Okay. So no, I want to move it. Well, never mind. Okay, maybe that's good enough. Let's see. Yeah, so this curve is broken at 1 and -1. And
Somebody wrote a question.
okay. Okay. Would that person that wrote the question just speak so I don't have to go back to the screen?
I can read it.
Okay.
So he asked, so no limits exist at breaks?
Yes. Well,
Thank
okay.
you.
Okay, wait a minute. No, that's not entirely true. Okay, we had a break. We had a break here with this one, right? This one's got a break at 1, but the limit exists anyway. Because because in this one I can just fill in the hole, so to speak, and get a nice unbroken curve. Yeah, I can fill in the hole here. I can't fill it in. Don't want that. I can't really fill in. These are kind of big breaks. And I can't just add a point there and a point there and make it be unbroken. So if you can make it be unbroken by just filling in a point, then the limit exists. If there's a big jump, no. And in this case, there's no limit at -1 or 1. Okay, does that answer the question?
Does it say it has no limit because like it jumps from one line to the next and it does it so on the same spot?
Right. In fact, let's look at this in detail. Okay. Okay, so, well, let's look at what happens at x equal to -1. If I take numbers less than -1, okay, for numbers less than -1, so that would be over here. Yeah, there. The F values are going to be up here, right? Well, the F values are really on the y-axis, but points on the curve or on that straight line there. And as the x is coming into -1 from the left, the f values are coming down to, let's see, what is it? They're coming down to 3. Okay, actually that point is supposed to be, that's 3 right there. Yeah, coming in from the left, the f values are approaching 3. In fact, that we say, okay, it's a one-sided limit there. So yeah, I was going to talk about that a little today. So let's just go ahead and talk about it. The limit as x, no. Okay, this is going to take me some serious learning. Every time I move my hand, I bring up something I don't want. Only if I want to do it, I can't find it. Okay, so the limit is x approaches 1 from the left. Going to use that notation. So I'm only going to come in from the left side of f of x. Is the limit as x approaches 1 from the left of, okay, how was f defined for the x is less than -1? It was defined to be 2 minus x. And that limit, okay, 2 minus x all by itself is unbroken. That limit is 2 minus, that's supposed to be -1, isn't it? And that's supposed to be -1. Okay. That limit's 1. Coming in from the left, the limit is 1. And I'm just going to erase this because it's problem. All right. But coming in from the right, we get something different. If I come in from the right, we use that notation. So I'm only considering x is bigger than 1 now. Well, let's go back to our curve. Coming in from the right, that means that now I'm looking at x's between -1 and 1. Okay, yeah, I want x bigger than 1, but close to it. So that means I'm using this piece. And, okay, and that corresponds to this part of the curve. Okay, and that means now that, okay, I'm coming in like that, coming in to the right to -1. I'm going to get f values down here. And in fact, these f values are going to be approaching -1. Yeah, so the piece of the function I'm using right now is that x part, and that's a nice unbroken curve all by itself, playing the role of a piece of this function. I do not want the keyboard. And that's just -1. Okay. And 1 is not equal to -1. And that's a problem as far as the limit goes. Yeah. So again, the limit as x comes into -1 from the left of f of x, Well, that's that 2 minus x piece. And that has a limit of 1. Coming in from the right of f of x, that means I'm using the x piece of the function. That limit is minus 1. Those two numbers are not the same, so no limit. If the limit from the left is not equal to the limit from the right, there is no limit. And that's the problem here. Yeah, there's yes, you do have class. Okay. I'll wait a minute. Okay. Let me see if he's trying to get in. Which means I have to go through this process. Okay, so thank you guys for coming in on time this morning. It really helps if no, he's not. Okay, well, yes, we have class every day, but I will answer his email later. Well, while I'm here, any questions? Nope. Okay.
Well,
Okay.
I did have one. Would a limit exist, judge upon what we just went over, would it be safe to assume that a limit wouldn't exist on a function that would produce asymptotes?
Yes.
Okay.
Yes. That's okay. I haven't really talked about that yet. We're just getting started. But yeah, anytime there's a vertical asymptote, no limit. That's true. Anything else? Okay. Let's see. Back to the screen. Okay.
Miss Kennedy, can you hear me?
Yes.
Oh, okay. Okay, I'm new here because my schedule was changed by the university, so I missed the last class yesterday. I didn't know about it. I just get it fixed yesterday with my counselor. And I would like to know if you're gonna post the notes on Blackboard because I missed the class from yesterday.
I'm not going to post them on Blackboard, but I'm going to email them to everybody. Okay. And would you just, okay.
Okay.
Let's see.
I'm Jefferson, by the way. I'm sorry.
Okay. Send me an email, please.
Okay.
It's hard to see me after class. Okay.
Yeah, I know. I'm sorry. Yeah, I have a question too about the homework too because I don't know where to get my homework. Yeah.
Right.
Yeah.
Okay. Let's see. When I let everybody go, would you just stick
Mhm.
around for a minute?
Yes,
And we
no
can
problem.
talk about it.
Yes,
Okay.
no problem. Thank you.
Okay. Let's see. Let's go. Okay. Yeah. So you can have little holes and still have a limit, but there's no big jump there. Okay. If you can fill it in and get a nice unbroken curve, it's got a limit. Okay, but there's no way to fill these in and get a nice unbroken curve. Yeah, the problem at -1 is that when you come in from the okay. Somebody does one in. This is going to be a problem. Okay, there.
It's 8:43. Don't let them in.
Point. Okay. Well, okay, I may have to make some rules about that because it's very distracting to have to go back and forth like this.
The person who just joined in the waiting room is already on the Zoom call. He's just joining so that he can see and y'all can see him and hear him.
Okay. Huh. Okay. Whatever that means. Okay, screen. Yes, I know that. Ah, how come my finger's not working? There we go. Okay. Yeah, so there's no limit at -1, and this kind of same thing happens at +1, right? If I look at the limit as x approaches 1 of this function, from the left, okay. Well, okay, if I'm coming in from the left, I'm using the middle piece there. And the rule on the middle piece is that f of x is x. And that limit, I can just substitute in now, 1 for x. Okay, coming in from the right, though, I'm coming in on another piece. I'm coming in on the parabola part piece. The x minus 1 squared, okay. And, okay, that's a nice, by itself, an unbroken thing, so I can just substitute in. That's 1 minus 1 squared, that's 0. And 1 is not equal to 0. The limit from the left is not equal to the limit from the right, so there's no limit. Or, yeah, at x equal to 1. I should call it A. Okay. But everywhere else, there's no problem. The limit exists for every single number except 1 and -1. Yeah, so the answer to this question is x equal to 1, x equal to -1. And okay, any questions now? I don't hear anybody. Yeah, so we talked a little bit about one-sided limits, and what time is it? Okay, we got it. Yeah, so one-sided limits, in fact, this is a rule. The limit as x approaches a, so that's when I just write this, I mean, coming in from both sides, exist if and only if the limit as x approaches a from the left of f of x exists. The limit as x approaches a from the right of f of x exists. And those two are equal. Okay, so that's a rule. And okay, I guess I should write out the definition of the limit, a one-sided limit. It makes it easier to talk about things, and they're interesting on their own anyway. So annoying. Okay. The limit as x approaches a from the left, how you read that, is L if you can make f of x arbitrarily, so as close as you want, arbitrarily close to L by taking x sufficiently
I'm sorry, can I just ask, after the parentheses from left, is that a less than sign? Or is it is less than?
Oh, no, that's an is.
Okay, yes.
Okay, let me. Is, okay. Was that what you were asking about?
Yes, ma'am.
Okay. Yeah. Got to get used to this. Got to quit bringing up all those other things. It's going to take some time. Okay, but yeah, so the only difference here is we're only considering numbers less than a. Okay. And you define, I'm not going to write it out, but define the limit as x approaches a from the right of f of x is L in a similar way. Yeah, except when they're coming in from the right, you take the x is greater than a. Okay, maybe this is a good place to stop. Okay, so before I leave this screen, is there any questions? I think I pretty much covered what I wanted to today. So let me go back.
So this is being emailed to us?
Yeah, it will be. I have a class right after this. Okay, so it won't be right after
Okay.
your class, but after that class ends, I'll be sending the notes to you. Okay.
Okay. Thank you.
Let's see if I can go back to Zoom.
Excuse me.
I'm sharing. I know I'm sharing the screen.
Excuse me.
Okay, I think we'll call it a day. I will be emailing the notes to you. Any questions before we go? except for the guy that joined late, the new guy. Okay.
I
Okay.
have a question.
Okay. Who's this?
This is Ken Aron.
Okay. Let's see if I can find you. Okay. Gotcha.
I just wanted to like ask if you can like give me your email or like see if you're receiving any of my emails because like I'm still not getting an email from you.
Uh, I actually put you on my list yesterday. I mean, put you on the email list for the class. And I added you. So you should be, you're not receiving anything? I got
No, like
some from you.
yeah, I remember when I sent something from you to you, but like when I search your name in my email, like you don't pop up at all.
Okay. Well, I will try to send you everything today. Okay. I did add your email to the class list. I did remember to do that yesterday, but send you,
Kendall,
I'll send you the syllabus and all that.
Kendall, what's your email?
I'll send it to you.
There is an email that I'm using for the class. Okay. And yeah, I will check it out, Mr. Rowan. All right. Okay. So everybody can go except for the guy that had that just joined the class.
Yeah, it's me. I'm sorry.
Okay. Okay.